I'm going to be solving some exponential equations today. There are two situations involved with exponential equations. In an exponential equation, there's the variable is in the exponent, or variables are in exponents in more advanced cases, super advanced cases. There are two situations that are convertible to a common base. Some of them are. Others are not convertible to a common base. Now with the Swakowski-Cole textbooks, they use natural log if the base is e. They use a common logarithm for any other base. Okay? So if convertible to a common base, you don't have to use a logarithm. But logarithms will work for any exponential equation. So not all exponential equations can be done this way. But all exponential equations can be done using logarithms. So we'll use example 1 to illustrate this. So there's option A. That's the easiest because 2 and 128 are both convertible to a power of 2. 128 is equivalent to 2 to the 7th. Now, that being the case, if this equals this, and the base equals the base, that requires the exponent to equal the exponent. 3x plus 13 is 7. Subtract your 13. And 3x is negative 6. Divide off the 3, divide off the 3. X is negative 2. Now, what would have happened if we had used a logarithm? Okay? Well, here's what we would have done. Log of 2 to 3x plus 13th equals log of 128. All right? This would have allowed me to take the 3x plus 13 to the front in parentheses times log 2, using that property there. And this would have been log 128. Okay, we're not going to distribute the log through. Instead, we're going to divide off the log on the x side, on the left side. So log 128 over log 2. So I end up with 3x plus 13. Get my calculator out. Log 128 is about 2.017 something divided by log 2. 7. And then from here, it becomes the same problem. So 3x equals negative 6. Divide off the 3, divide off the 3, x is negative 2. Okay, see how I am on board space. Okay. Here's an example 2. I get my examples off on a document off camera, so I'll be back in a moment. 9 to the x plus first equals 27. 27. To the x minus 4th. Okay? Both of these are powers of 9, or powers of 3. So 9 is 3 squared. I'll put the original exponent in parentheses. Okay? I'll do that again. I'll repeat this. Both of these are powers of 3. 9 is 3 squared. Put the original exponent in parentheses. 27 is 3 cubed. Put the original exponent in parentheses. Okay? This allows me, since this equals this, and the base equals the base, that requires the exponent to equal the exponent. I'll go ahead and do the distributive property. 2x plus 2 equals 3x minus 12. Okay? I got x's on both sides. I don't like that, so I'll subtract the 3x. X plus 2 is negative 12. Subtract your 2, subtract your 2. X equals negative 14. Okay? Again, a logarithm could have worked. I could have used a logarithm, but we'll skip the logarithm. Log is an option, but not done this time. Log is an option, but we're not doing it this time. Okay? So I'll pause here and I'll set up another example. Okay, now what I have done is I kept example 1, I've erased example 2, and I'm putting example 3 on the board. Okay? So, do. 5 and 26 are not convertible to a common base. So what we're going to do is we're going to do the logarithm. Okay? So I'll have log of 5 to 4x minus first equals log of 26. Okay? That will allow me to take this to the front as in parentheses. All right? And then we're going to divide the log on the left side. All right? Cancels over here. We have 4x minus 1 equals log 26 over log 5. Okay, and then we're going to add 1. So I'll have 4x equals log 26 over log 5 plus 1. Okay, next I need to divide off the 4. I'll be dividing all this over 4. So that leaves me x equals log 26 over log 5 plus 1 over 4. Okay? Put another way, let me go ahead and move that up a little higher. X equals log 26 over log 5 plus 1 over 4. Or another way you could have put this is x equals log 26 over log 5 plus 1 divided by 4. That's another way that could have been expressed. Okay? Now the approximate solution, so these are exact. And now I'll do an approximate. X is approximately equal to one thing at a time. Log of 26 is approximately 1.41497 blah 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 divided by log of 5. I have 2.02 for blah blah blah. Add 1, hit enter or equal. That's 3.024 divided by 4. approximately 0.756. This is approximate. Okay? All right. I'm going to stop here, pause here, and clear the board. Okay. Example 4, we're going to solve e to the 0.015x power equals 14, and that's what we're going to use right there. So I'm simply going to take the natural log of e to the 0.15x equals the natural log of 14. Now, this is equivalent to log base c, okay? ln is log base c. So, log base c of e to a power simply takes the exponent out of the exponent. All right? Next, we simply divide off that 0.15x, or that 0.15. And x is approximately, because it says round to 1 decimal place. I'm going to take the natural log of 14. I get 2.639 blah 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 divided by 0.15, and the value rounds to 17.6. Okay, here we're going to have to divide off that 12. To isolate the base. Okay? So that leaves me e to the 0.05t equals 6. All right, same as before. It's base e, so we're going to use a natural log. All right, since that's log base c, that allows us to take the 0.05t out of the exponent. The final step is to simply divide off the 0.05. Okay, I'll try to make that more legible. Natural log of 6 over 0.05. Cancel those. And t is approximately, because it says to round. I'll take the natural log of 6. I end up with 1.791759 blah 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 divided by 0.05. I end up with approximately 35.835. Okay. Neither one of these two problems asks for the exact value. It wanted us to round. I asked to round a certain number of decimal places. This problem, we are going to give an exact value and a rounded value. Okay? So do. It's e to the power equals a number, so I'm going to take the natural log of e to the 2x plus first equals the natural log of 15. That takes the exponent out of the exponent. Okay, now I will subtract the 1, and I end up with 2x equals the natural log of 15 minus 1. Divide off the 2, divide off the 2. Natural log of 15 minus 1 over 2. Don't combine those because they're unlike terms. Okay? So, x equals the natural log of 15 minus 1 over 2. This is an exact solution. Also called a rational form. Okay? Irrational form is another way this would be put. Okay, B. X is approximately, so I'll take the natural log of 15, hit enter, equals natural log of 15, I get 2.708, blah, 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 subtract 1, now it's 1.708, blah, 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 then divide by 2. I get x is approximately 0.854. By the way, this is also called irrational form. So we can call this exact solution. We can call it irrational form. Okay, both terminologies are used to describe that situation. Both of these describe an exact solution of a logarithm. Okay? Exact value, exact solution, and irrational form. All right, so I'm going to take this, I'm going to stop here, pause here, take all this off the board and do another example. Okay, the main event for right now is going to be example 7. Okay, but we're going to go back to example 3 as a review before we take on this problem. Okay, 5 and 26 are not writable in terms of a common base, so we're going to use the common logarithm. Okay, so I'll take the common log of 5 to the 4x minus first is log of 26. Allow me to take the 4x minus 1 to the front. Okay, now the next thing I did was divide off the log on the left side, leaving me, those cancel, 4x minus 1 equals log 26 over log 5. Next thing I did was I add my 1. I had 4x equals log 26 over log 5. And then divide off the 4. So x equaled log 26 over log 5 plus 1 all over 4. Okay? Now, what we're going to have to do here is take the log of both sides. So, log of 5 to 2x plus first equals log of 6 to the x minus second. And these are going to the front. So I have 2x plus 1 log 5 equals x minus 2 log 6. Okay, similar to what happened here. Okay, except on both sides. Now, like I did here, I'm going to go ahead and divide the log 5 off this side, off the left side. And they'll cancel over here, and I'll end up with 2x plus 1 equals that. Okay? Now, what I'm going to do here is I'm going to go ahead and do the distributive property. So this is going to be x times log 6 over log 5. So distributive property time. Okay? Minus 2 log 6 over log 5. Okay? So on this side I cancel, on this side I distributed. Now, the goal here is to get the x's to one side. Get x's to one side and isolate. Okay? So the idea here is I got x's on both sides. I'm going to get rid of the one that's on the right side. All right, and I'm going to subtract it from the other logarithm, or from the other x term. So I'll have 2x minus x log 6 log 5 plus the 1. So this x term minus that x term plus the 1 equals, negative 2 log 6 log 5. Now, the next thing to do was to isolate the x terms. So I'll subtract that 1 because it doesn't have an x term in it. So now I have 2x minus x log 6 over log 5 equals negative 1 minus 2 log 6 over log 5. Okay, I'm going to go ahead and copy this up here. I want to make sure that it all fits on camera. It does. Okay, good. Now, what I'm going to have to do next, factor out x and divide. Okay, so that's the next step. Factor out the x and divide. So these two have an x in them. I will take it out. And finally, I'm going to divide it off this, I'm going to divide it off that. So x equals this over this divided off here, divided off there, and became a denominator. And we can call that done. I have two more examples here. For both of them, I'm giving the exact solution, and then I'm approximating it to 2 decimal places. So we'll start with this one. This is 9 to the 7x power times 13. That's equivalent to 78. So the first thing we have to do is isolate the exponent base. So I'll divide off the 13, and I end up with 9 to the 7x power is 6. Now 9 and 6 cannot be rewritable, or not rewritable in terms of a common base. So we'll use the common logarithm. So I'll take logarithm 9 to the 7x power equals log of 6. That allows me to take the 7x to the front. So I'll have 7x log 9 equals log of 6. Okay? Like the previous problem, I'm going to divide off the log that's on the left side. These cancel, and 7x equals log 6 over log 9. Okay, all I'm going to do is copy the problem over, the problem at this point up here. And continue. I have 7x, so I need to just divide off that 7. Now, instead of putting in the denominator, I'm going to actually use an arithmetic division symbol. So x equals log 6 over log 9 divided by 7. Okay, and I want to make those division symbols more clear. Alternatively, you could also describe this as x equals log 6 over log 9 divided by, well, or log 6 over log 9 over a bigger fraction bar in 7. Now, we're going to do b. So these are the exact values, either this or this. Okay, your choice. This is more calculator friendly. So I'm going to take my calculator, log of 6, that's approximately 0.778 blah 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 divided by log of 9. I have 0.815 or 0.81546 blah blah blah, then divide by 7. Okay, so my calculator spits out 0.11649 blah blah blah, who cares? Okay, so it wants us to round to two. We're supposed to round to 2 decimal places. That's second decimal place. That's a 5 or greater, so we're going to x equals 0.12. Okay? All right. This next one, like before, I need to isolate the base and the exponent, so I'll divide off that 55. So I end up with 7 to the x plus 9th power is 2/11 when that fraction is reduced. Okay, like before, I'm going to use the common logarithm. And now I'll take this exponent to the front. And I end up with x plus 9 log 7 equals logarithm of 2/11. Okay, and like before, I'm going to divide off the logarithm on the left side. Like so. Okay, these cancel. That's what they're supposed to do. We end up with x plus 9 equals log of 2/11 over log 7. I'm going to copy this exactly as is up here. All right? So x plus 9 equals log of 2/11 over log 7. The final order of business is to subtract that 9. So x equals log 2/11 over log of 7 minus 9. Okay. Now, next I'll do B. So, I'm going to type in log, open a parenthesis if your calculator didn't. So for this one, you're going to need to open a parenthesis if your calculator didn't. So 2 divided by 11. Close the parenthesis. So log of 2/11 in parentheses, I have negative 0.74 blah, 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 blah for just this part. Negative 0.74 divided by the log of 7. Now I have negative 0.876 and subtract the 9. Negative 9.876, blah, 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 who really cares? Second decimal place, I'm rounding up. X is approximately negative 9.88. What I intend to do here is some exercises with exponential models, some examples with exponential models. So the fictitious town of Zwitzville, okay? I don't know whether a real town of that nature exists or not, but it's a fictitious town made up for this problem. So if there's a Zwitzville somewhere, pretend it's in another state or another country, okay? So Zwitzville had about 1,400 people in the year 2010. It has been growing at about 3.6% annually. A, create a model for the population. B, predict the model in 2035. round to the nearest hundred. Okay? So, before we do, so here's the idea, okay? Exponential models are based on the assumption of a percent growth or percent increase, okay? So, amount equals original value equals original times 1 plus or minus r to the tth power, okay? Where this is percent change as decimal. Okay? So, since we're doing population, we could either do capital P or capital P of T. I propose capital P of T. So the original amount is 1,400. We're going to base this off the number of years since 2010. Years since 2010. Okay, so 1,400 times 1 plus, the reason it's plus is because it's growing at 3.6% annually to the tth power. Okay, so P of T equals 1,400 times 1.036 to the tth power. Okay, B, 2035 equals 25, so T would be 25. Okay, the year 2035 says T is 25. Why? Because this is 25 years after 2010. All right, so P of 25 equals 1,400 times 1.036 to the 25th power. Now, most calculators, you could just enter this in exactly as is. 1,400 times parenthesis 1.036, your generic exponent button, 25. This was what it would look like on the calculator that I'm using. Okay? So, this is approximately 3389.4. Okay? But to the nearest person, that because it's population, okay, we normally round this to the nearest whole person. 3390 people. But to the nearest 100, as population, we normally round the nearest whole person. But the directions say to round to the nearest 100. So if we're rounding the nearest 100, that is 3,400 people. The nearest 100, 3,400 people. Okay, so here's another question about when would the population reach 4,500? Okay? So, we know from part A what the model is. You need to see that again, rewind. Okay? To do C, we are interested in when the population equals 4,500. Okay? My unknown is on the right, so I propose to switch the sides because I prefer my unknown on the left, and most people do too. I'm going to divide off the 1,400 to isolate just the base and its exponent, and I will reduce this side. So 1.036 to tth power is 45/14. Okay. That is a base other than 10. That's a base other than E. So I'm going to use the common log, which is base 10. Okay? If I take the log of this side, I have to take the log of that side. Now, since this is base 10 and that base is, since this is base 10 and that is not 10, I will take the t to the front. Okay. Now the next thing I'm going to do is I want to divide off that logarithm, okay? Because this is t times that log. So I propose to simply divide it off. So t equals log of 45/14 divided by the log of 1.036. I'll round. So I have, look, my common log, log, parenthesis, 45 divided by 14, balance the parenthesis like I have on my calculator. Hit enter or equal. With that number still on my calculator, I will then divide by log of 1.036. I get approximately 33 years. Okay? If we add that to the year 2010, 2043. Okay? That is the year you can expect the population to reach 4,500. Okay, here I'm going to discuss a other type of interest, okay? Compound interest. Compound interest has two subtypes, continuous and periodic. Now, some courses include periodic only, okay? College algebra classes, business math class, advanced business math classes, applied calculus classes, which is also business, often usually business calculus, usually include both of them as well. I think it's easier to start with continuous, so that's what I'm going to do first. Okay? So, but I will at least give people an idea of what this looks like for later. Okay? So, accumulated value equals the principal, and then this is where things change, become different between the two of them. E is a constant. It's 2.71. It's approximately 2.718281828,459, and then it goes all over the place forever. Okay? You'll hit shift or second. You'll hit shift or second LN on your calculator to get to that feature. Okay? For periodic, it's 1 plus the raised decimal, and this is still time. This is what causes the most confusion because it's usually never given as a number. Okay? It's a number of compoundings per year. Now, if it says it's compounded monthly, there's 12 months in a year, so it would be 12. If it's compounded annually, there's only 1 year per year, so n would be 1. If it's compounded quarterly, there's 4 quarters in a year, so n would be 4. And semi-annually, that's every half year, so that's twice a year. Okay? So, Purple Grove offers 4.45% interest compounded continuously. If 1,040 is deposited now, find balance in 9 years. So do. It says it's compounded continuously, so the appropriate formula is the continuous compounding formula. Okay? Now, before I start plugging things in, I try to identify what the variables are, what the variable values are, because sometimes it's not as simple as it seems. So 1,040 is what we're starting with. That's our principal. We're looking for what the balance is going to be, an accumulated value in 9 years. Rate, either move the decimal point over 2 places or just divide that by 100, is 0.0445, and t is 9 years. So A equals 1,040 times e to the 0.400, e to the 0.0445 times 9th power. Okay? I always every calculator handles this differently. So what I would recommend you do is multiply this out. Okay? So leave the E, 0.0445 times 9 is 0.4005. Okay. Now, on my calculator, which is the Casio, you will see, and you will typically see an LN button. On my calculator, it's right there. Some calculators, it may look like a capital I, but it's actually LN. Okay? Right above that LN, you will see e to a power. Okay? Now, I can't get this thing to focus. Okay? But above, you should be able to find e to a power if you hit shift or second. So, for me, I would just type in 1040 times shift or second, depending on what your calculator says, ln. So again, 1040 times shift or second ln. Okay? This is what it looks like on the calculator that I'm using. Okay? And in the nearest set, that's 2 decimal places, 1552, sorry, 0.27. Okay? Now for this one, it's still continuous. A equals PE to the RTth power, where A equals, P equals, R equals, T equals. Well, rate is still what it was before. T is 9. Now that 1600 is what we're hoping to have in 9 years. That is an accumulated value. We don't know what we're depositing, what we're starting with. As I said, determine what your values are before you start plugging things in. So I want to know when 1600 will equal e to the P times e to the 0.0445 times 9th power. Okay, that's my unknown. That is what I'm solving for. So what I'm going to do is, since that's my unknown, I'm going to switch the side and move it over here. Okay, so I have P. I am going to go ahead and simplify the exponent. I'm going to pretend that I don't know what the answer to this is. So 0.4005 times 9, sorry, 0.0445 times 9 gives me 0.4005 equals 1600. Now, my goal is to undo, I got P times this e to something. I'm going to do the multiplication by dividing. And yes, that is the arithmetic division symbol, and that's what I'm going to use. So P equals 1600 divided by e to the 0.4005 power. Okay, so I'll do similar to what I did here, except instead of timesing, I'm going to divide. So 1600 division, shift or second, ln, 0.4005. This is what it looks like on my calculator. Okay, if I can get it to show. Again, I'm sorry the lighting isn't very good in here. Okay, not for this. I have to darken it because I want the board to be very visibly clear. Okay? Maybe this other calculator will be a little clearer. Yeah, that looks better. Okay, hit enter or equal. Okay, so the nearest cent, that's going to be $1,071.98. The problem also said it wants the nearest dollar. So the nearest dollar, that is $1,072. Unless given reason to do otherwise, unless given reason to do otherwise, assume nearest cent. Unless given reason to assume otherwise. Okay, this next part says, how long would it take for 1,040 to grow to $1,700? Well, it's still compounded continuously, so this is still the appropriate formula. Okay, so A equals, P equals, R equals, T equals. So the accumulated value is going to be 1,700, and we're starting with 1,040. The rate is 0.0445, and T is unknown. Okay, that's the question. So I want to know, when will 1,700 equal 1,040 times e to the 0.0445 teeth power. Okay, T is my unknown, so I'm going to go ahead and switch the sides so it's on my left. Okay, and now I'm going to go ahead and divide out that 1,040 and reduce. So e to the 0.0445 teeth power is 170. Actually, it can be reduced even more. Well, actually, I'll just truncate those zeros. And then these two are also divisible by 2. So 85. So 1,700, 1,040ths. That is 85/50 seconds. You don't actually have to reduce if you don't want to, because it'll come out the same in terms of, decimal form. All right? So that's base E, so I'm going to use a natural log. Like so. Okay? Since ln equals log base E, that allows me to take, that cancels raising e to a power and leaves me 0.0045t equals the natural log of 85/50 seconds. Okay, I'm going to diagonalize the fraction because I might be running low on space. Okay, so the next thing I'm going to do is divide off that 0.0445. Okay? I'll use a division symbol, the arithmetic division symbol. Okay, so T is approximately, so on my calculator, I'm going to type in the ln, 85, division or fraction bar, 52, balance the parentheses. Make sure that the parentheses are balanced. I go ahead and hit enter or equal, 0.4914 something, and then divide by 0.0445. T is approximately 11.043 years. Okay? Okay. D, find doubling time. Okay, well, we'll find the doubling time. So here it goes. Maybe we could, you could literally make any number up and just double it. okay? But we've been using 1,040 for a deposit, so we'll use 1,040 for a deposit, okay? Suppose P is 1,040. How long for 1,040 to double to 2080? Okay, if you want to do 100, you'd be how long for it to double to 200? If you want to do 1,000, how long for 1,000 to become 2,000? It really doesn't matter what you start with as long as you double it. So this would be my P, this would be my A. Okay, so A equals PE to the RTth power because it's continuous. Okay, so how long? So A equals, P equals, R equals, T equals. So A is 2080. P is 1,040. R is 0.0445, and T is I don't know. That's the question. Okay, so I want to know how long for 2080 to become equal to 1,040 e to the 0.0445 teeth power. So I propose to switch the sides and divide. So divide this off, and we have e to the 0.0445 teeth power equals 2. Okay? It's base e, so we'll use a natural log, which is log base e. All right? So that takes that out of the expo, and we have 0.0445 t equals a natural log of 2. Okay? All I need to do now is divide off that 0.004, or that 0.0445. Might want to put that in parentheses to be on the safe side. And t is approximately, so natural log of 2, hit enter or equal, I'm looking at 0.6931471, blah, blah, blah. Okay, and then divide off the 0.0445. Okay, I'm looking at approximately 15.58 years. Okay? Analogously, part E, find the tripling time. Okay? So let's suppose P is 1,080. Okay? Or 1,040, which is what we've been using. Okay? For our deposit. You can, for the purposes of finding tripling times, doubling times, you can make up any number and double it. That's pretty much all you have to do. So suppose P is 1,040. How long for 1,040 to triple to 3120? PA. Okay? So, if A equals PE to the RTth power, I want to know, so A equals, P equals, R equals, T equals. So A is 1,040. P is, we're starting with 1,040. We're tripling it to 3120. Okay. The rate is still 0.0445, and T is we don't know. So when will 3120 equal 1,040 e to the 0.0445 times 9th power, times tth power. Okay, I'm sorry, my brain went back in time. Okay, I'm solving for t. So I will switch the sides and divide. So 1040, because t is my unknown, so I want to move that side to my left. E to the 0.0445 tth power equals 3120. Divide off the 1040. And I'm left with e to the 0.0445 tth power equals 3. Okay? Doubling time, you end up with 2. Tripling time, you end up with 3. If you ask for quadrupling time, you end up with 4. Okay? So, that's e to an unknown power. We'll do natural log, which is log base e. Okay? That takes this that undoes the exponentiation, which just leaves me the 0.0445 t. Okay, and then I'm going to divide off that 0.0045. Sorry, that 0.0445. Okay, I'm going to put it in parentheses and just use a division symbol. Okay, so natural log of 3, hit enter or equal. I'm looking at 1.0986 blah blah blah. Divide by the 0.0445. I'm looking at approximately 24.7 years. Okay. Purple Grove Credit Union offers 4.55% interest compounded monthly. Okay, if 1,040 is deposited now, find balance in 9 years. So it is a non-continuous. That means it's monthly, it's periodic. So this is the appropriate formula. Okay? So A equals, P equals, R equals, N equals, and T equals. So N is 12. It's compounded monthly. Okay? The rate is 0.0455. Time is, in this context, 1,040 is deposited now, find balance in 9 years, and we're starting with 1,040. We don't know what the accumulated value will be in 9 years. That's the question. So A equals 1,040 times 1 plus 0.0455 over 12 to 12 times 9th power. Okay? I strongly recommend you clean this up and never round. Never round. Okay? Never round that. Never round. I'll erase that, but I want to make sure it gets read. Never round. If it doesn't terminate, if it's a repeating decimal, then you keep it as is in parentheses. Okay? That's 108. I'll pretend that that's simply 108. So A equals 1,040. That, and I'm going to see if that divides cleanly. I don't think it does. So 0.0455 divided by 12 plus 1. So what I went ahead and did is I went ahead and took the 0.04, divide first, then add. Okay? And as you can see, there's a bar on top of my 6 that tells me it repeats forever. Okay? So that doesn't divide cleanly. So I'm going to leave it as is. most problems will not round cleanly, so I recommend you get in the habit of just leaving these in parentheses. Okay, now most calculators, this isn't going to be a problem. You just type in the 1040 times, open a parenthesis. I'm going to say that again. 1040 times, open a parenthesis, 1 plus 0.0455 divided by 12. Balance the parenthesis and then generic exponent button 108. So the nearest cent I got $1,565.09. Okay, unless given reason to assume otherwise, you will round to 2 decimal places to the nearest cent. Okay, so for this one, same formula. Okay, so A equals, P equals, R equals, N equals, and T equals. So the cumulative value is going to be 16. So it's compound monthly, so N will be 12 throughout this problem. The rate is 0.0445 or 0.0455. Sorry, my brain was still on the last example, on another example. T is 9. And this 1600 goes with the future value. We don't know what we're starting with. That's the question. Okay? So I want to know 1600 equals P times 1 plus 0.0455 divided by 12 to 12 times 9th power. Clean that up, and since P is my unknown, I'm going to switch the sides. Okay, and I hope everything is still visible on screen. It is, good. Okay, so P times 1 plus over 12, that's 108, equals 1600. Okay, so my dream is to divide this off, because I got P times a whole bunch of stuff. So I'm going to divide off that whole bunch of stuff. Okay, so P, that looks more like a D, I'm sorry. P equals the 1600 divided by 1 plus 0.0455 divided by 12 to the 108th power. Okay? If you're using a Casio and most Texas Instruments calculators, this is not a problem. If you're using one of those calculators that doesn't support the order of operations, this is a little dicey. Okay? But for those of you who are using a good calculator, this is not a problem. Just type in the 1600 division, parenthesis. Very important that you include that parenthesis. 1 plus 0.0455 division 12. Balance the parenthesis, your generic exponent button 108. To the nearest cent, I got $1,063.19 rounded to 2 decimal places. Okay. Okay. So now we're going to go to more advanced problems. How long would it take for 1,040 to grow to 1,700? Again, it's compound monthly, which is periodically. This is the appropriate formula. Okay, where A equals, P equals, R equals, N equals, and T equals. N is still 12 because it's monthly. Okay, we don't know the time. That's the question. The rate is still 0.0455, and that's what we're starting with, and that's what we hope to end with. Okay, so I want to know how long will it take for 1700 to equal 1040 times 1 plus r over n. Sorry, I'm going to replace those values with their appropriate numbers. 0.0455 over 12 to 12t power. Okay? T is my unknown, so I'm going to switch the sides. I'll also do this division. So 1040 times 1 plus 0.0455 over 12 to 12t power equals 1700. Okay? I will go ahead and divide off this 1040, and I'll reduce, although you don't really need to reduce. Okay? So 1 plus 0.0455 over 12 to 12t power. I'll reduce this to 85/50 seconds. Okay. I want to get this t out of the exponent. So I'll take the common log. Since it's a base other than e, I'll use the common log. All right, so since it's log base 10 of something other than 10, the 12t can go to the front, and I've got 12t log of 1 plus 0.0455 over 12 equals log of 85/50 seconds. Okay? I'm going to make that look more legible. 85/50 seconds. Okay. Now I want to get the 12 by the t by its lonesome. So what I will propose to do is divide both of these off. So t equals log of 85/50 seconds divided by 12 divided by log, common log, of 1 plus 0.0455 over 12. Make sure you balance the parenthesis. Okay. All right, so let's do this. Common log of parenthesis. Make sure you got a parenthesis. 85 division or fraction bar 52. That's one possibility. Here's something else. But make sure it's balanced with a pair of parentheses. Hit enter or equal for just that part, and I got 0.2134 something. With that number still in your calculator, divide by 12. Hit enter or equal. Now I'm looking at 0.01778,463, blah, blah, blah. Division. Common log. Parenthesis. 1 plus 0.0455. Division 12. Balance the parenthesis. Hit enter or equal. I'm looking at approximately 10.82 years. 10.82 years. right? Okay, find doubling time. Well, do. This is the amount of time it takes any amount to double. $100 to $200, $300 to $600, $1,000 to $2,000. You could literally plug anything in for the principal and double it for the accumulated value. But we've been using 1,040, okay, as a deposit. So suppose P is 1,040. How long for 1,040 to double to 2080? That's the question, okay? So I want to know how long it will take if we have A equals P times 1 plus R over N to the nth power. How long would it be for P, A, for 2080 to equal 1,040 times 1 plus 0.0455 over 12 to 12th power. Okay? Since that's my unknown, I'm going to go ahead and switch the sides. Okay? Then I'll do the division. And you end up with 1 plus 0.0455 over 12 to 12th power is just 2. Okay? Well, that's a base other than these, so we'll use the common log. And since that's a base, that's log base 10, and that's a base other than 10, so we can move the 12t to the front. So we have 12t log of 1 plus 0.0455 over 12 equals log 2. Okay, and then all I need to do is divide these two things off. Divide off. Okay? Those are meant to be division symbols. So t equals log of 2, I'll put it in parentheses to be on the safe side, divided by the 12, divided by the common log of 1 plus 0.0455 over 12, balance the parenthesis. You know what, I could just go ahead and do that right there. Okay, so what I'm going to do, common log of 2, hit enter or equal. I'm looking at, for just this part, I'm looking at 0.301 something. Okay? Divide by 12. Now I'm looking at 0.0258 something. Divided by common log. Be sure to use a pair of parentheses. Parenthesis 1 plus 0.0455 divided by 12. Balance the parenthesis. Hit enter or equal. I'm looking at approximately 15.26 years. Okay?